We're going to start chapter 8, conic sections. So we're going to look at the circle and parabolas first. These are the shapes that we're going to look at for this chapter. We'll look at circle, ellipse, parabola, hyperbola. The set of points in a plane, each of which is equal distance r from a fixed point, is a circle. The point HK is the center of the circle, and the distance r is the radius. So we're going to start off with writing this formula somewhere as in our summary sheets. A circle with the center at HK and the radius r has this equation: x minus h squared plus y minus k squared is equal to r squared. If the center is at origin 0, 0, then the equation would be simply x squared plus y squared is equal to r squared. Find the center, radius, form of the equation of a circle with the radius being 6, and the center is given to us as the point -3 and 4. We're going to graph the circle and give the domain and the range. So that's all we really have to do, is to substitute the value into the general equation of the circle. Here, since the center is given to me as -3 and 4, remember this -3 correspond to h, and 4 would be correspond to k, and the radius r would be equal to 6. So we're going to substitute that into our equation. X minus h squared plus y minus k squared is equal to r squared. Be careful with the signs. H is negative, so it would be x minus minus 3 would be x plus 3 squared plus y minus 4 squared. And since the radius is 6, you square that would becomes 36. So we can see the graph. Locate the center, -3 and 4, and from the center you're going to move up, down, right, left 6 units because the radius is 6, and you can see all these points. From there we can look at the domain. The domain is from -9 to 3. Domain would be value of x, and the range would be from -2 to 10. Find the equation of the circle with center at the origin and the radius being 3. We want to graph and find the range and domain. Since it says the center is at the origin, so we're going to start with the equation of the circle, which is x squared plus y squared is equal to r squared. And pretty much we're going to substitute the values there. R is 3. So we have x squared plus y squared is equal to 3 squared, which is 9. That would be equation of my circle. And I start from the origin. The center is at the origin. I'm going to move up, down, right, left 3 units because the radius 3, and then I can graph my circle. As you can see, the range would be from -3 to 3. That's the value of y. Domain also would be from -3 to 3. Use a graphing calculator to graph each circle. When you want to use a graphing calculator, we want to solve for y. We have x squared plus y squared is equal to 9. When you isolate y squared, then take a square root of both sides. So y would be equal to plus and minus square root of 9 minus x squared. So there are 2 graphs that you want to enter into your calculator. One is y1 would be square root of 9 minus x squared, and then y2 would be minus square root of 9 minus x squared. When you graph this, it would give you 2 semicircle on the graph. That would be the graph of whole circle. Here we have a circle that the center is not at the origin. If you want to graph this using your calculator, similarly you would solve for y, and then you just simply enter these 2 equations in your graphing calculator, and you would see 2 semicircle. That would be the graph of your circle. For real number d, e, and f, this equation x squared plus y squared plus dx plus ey plus f equal to 0 can be a graph that is either a circle or a point or empty. This would be an example that we want to see whether this graph is a circle or not. As you can see, this is not in the form of standard form. We need to complete the square twice, one for x and one for y, in order to get it in the form of general equation of the circle. So if I collect all the terms that contains x in it, which would be x squared and minus 6x, we do the same thing with y. We have y squared plus 10y. We are looking for a number to add here to complete the square. If you recall, you have to make sure that the coefficient of x squared and y squared are equal to 1 in order to use this method. You take the coefficient of x, you divide it by 2, and you square it, and that's a number you need to complete the square. So if I take negative 6 divided by 2 and the square m, that would conclude that I need 9 in order to complete the square for x. Similarly, for y, I take the coefficient of y, which is 10, divided by 2 or multiplied by 1/2. You square it, you get 5 squared, which is 25. So I need to add 25 here inside the second parenthesis to complete the square. When you do that, you need to add that to both sides of the equation so you don't affect the original equation. So when I add 9 inside the first parenthesis, I also have to add 9 to the right-hand side. Or we could look at it as adding and subtracting 9 from in one side of the equation and then move the 9 to the other side. Similarly, I need to add 25 to both sides of the equation. Now I can complete the square. So in this case, I can write this as x minus 3 squared. I complete the square. That would be y plus 5 squared. And now the whole thing would be equal to 9. So because 9 is greater than 0, the equation represents the circle. If you get the negative 9 here, then it won't. So in this case, we can see the center. The center would be 3 and minus 5. Remember, because it's x minus h squared plus y minus k squared. So k would be minus 5. And the radius is the square root of this number 9, which is 3. And we can graph that. We locate the center, 3 and minus 5. And from the center, we're going to move up, down, right, left, and then graph them, which in this case, the radius is 3. Find the center and radius by completing the square. This would be a good time for those of you watching this later at home to pause the session and see if you can complete the square on your own and see if you can get the same results. We want to make sure that the coefficients of x squared and y squared are equal to 1 in order to follow these steps. And then in this case, they both are equal to 1. We take the coefficient of x, you divide it by 2 and you square it, and that would tells us what number I need to add here to complete the square. I have 10 divided by 2, square them, we get 25, so I need to add 25 into the first parentheses, and I take negative 4 divided by 2, square them, I get 4, and then I need to add 25 and 4 to both sides of the equation, so I don't change the original equation. Now I can complete the square. The first one becomes x plus 5 squared. The second one becomes y minus 2 squared. Now I get equal to negative 4. So because negative 4 is less than 0, so there's no order pair with x and y, both real numbers, satisfy the equation, so the graph contains no points. So it's not a circle. Finding the center and radius by completing the square, this would be another place where you should pause the session, see if you can do it on your own. The difference here is we do have a coefficient for x squared and y squared. So what we need to do is we need to factor that 2 in order to make the coefficient of x squared and y squared equal to 1. So the first step is to gather all the terms that contains x, factor the 2, then you get 2 times x squared minus 3x. We do the same thing with y. And then now I can take the coefficient of x divided by 2 and square it and see what I need to add here. You have to be careful with this example, so it's slightly different from the last one that we didn't have a coefficient. So in this case, you would find that you need to take the coefficient of x, which is 3, divided by 2, and you square it. So in this case, I take -3 divided by 2, and I square that. They give me 9/4. That's why I added 9/4 here inside the parentheses. Similarly, you take the coefficient of y, which is 5, you divide it by 2, and you square it. That will give you 25/4. And that's what you need to add inside the parentheses. You're really adding and subtracting 9/4 and 25/4 inside the parentheses, and then you move that out. So what I really doing here is, I'm going to write up here, 2 times x squared minus 3x plus 9/4, and then I would put minus 9/4 plus 2 times y squared plus 5y plus 25/4 minus 25/4. I'm really adding 0 inside these parentheses. As you can see, I only need the one with the plus sign to complete the square. So I have to move that minus 9/4 and minus 25/4 outside the parentheses. And this 2 belongs to those terms also. So you have to be careful when you move it outside of parentheses, you're really moving 2 times minus 9/4. You're moving 2 times minus 25/4. And that's why when we move it to the other side, this would become 2 times 9/4, and that would be 2 times 25/4. So now I can complete the square. I would get 2 times x minus 3/2 squared plus 2 times y plus 5/2 squared. And if I combine what I have on the right-hand side, I would get 18. Now, if I divide each term by 2, then I would get my equation here. X minus 3/2 squared plus y plus 5/2 squared is equal to 9. And that is the equation of the circle with the center to be at 3/2 and minus 5/2. And the radius is the square root of 9, which is equal to 3. Then we can locate the center, and from the center, we're going to move up, down, right, left, 3 units because the radius is 3, and we can have our circle. The set of points in a plane, each of which is equidistant from a fixed point and a fixed line, is a parabola. The fixed point is the focus, and the fixed line is the directrix of the parabola. If you look at this parabola, if the parabola opens upward, this point inside the parabola is known as the focus, and the directrix would be in the other side of the vertex, and the distance from the vertex to the focus would be the same distance from the vertex to the directrix. The parabola with the focus at 0, c, and directrix is equal to y is equal to minus c, like this example here, has an equation of x squared minus 4cy. This would be the next equation that you want to include in your summary sheet now. X squared is equal to 4cy when the focus is inside the parabola and the directrix is, in this case, y is equal to minus c. Parabola has a vertex 0, 0, vertical axis x equal to 0, and opens upward if c is greater than 0, or opens downward if c is less than 0, as you can see in these 2 figures. The parabola with the focus c0 and the directrix x is equal to negative c has the equation of y squared minus 4cx. This is another formula you want to include in your summary sheet. The parabola has a vertex at the origin, horizontal axis y is equal to 0, and opens to the right if c is positive, or open to the left is c is negative. And that would be the graph. Find the focus, directrix, vertex, and axis of each parabola. The first one, we have x squared is equal to 8y. If you recall, 4c would be equal to 8. If you look at the equation of the parabola, this coefficient is equal to 4c. That's how you can solve for c. Divide both sides by 4. C is equal to 2. Since the x term is squared, the parabola is open vertically with the focus at 0, 2, since c is equal to 2, and the directrix y would be equal to -2. The vertex is at the origin, and the axis is the y-axis. And you can easily graph this knowing all these information. The second one, the coefficient of x is -28. So 4c is equal to -28. You solve for c. This is the parabola that the y is squared. So the parabola opens on x-axis. The parabola is horizontal with the focus at -7 and 0. Directrix as x equal to 7. Vertex is at the origin, and x-axis as axis of parabola. Since c is negative, the graph opens to the left, and we can easily graph that knowing all this information. Write an equation for the parabola. The focus is given to me as 2/3 and 0, and the vertex at the origin. Since the focus is -2/3 and 0, and the vertex is 0, 0, the origin are both on the x-axis, the parabola is horizontal. It opens to the right because c is equal to 2/3 is positive. So the equation would be y squared minus 4cx. Remember, we had that in our summary sheet. So we write this as y squared is equal to 4. C I know is equal to 2/3. So it would be y squared is equal to 8/3x. Simply multiply these numbers. Vertical axis, vertex at the origin through the point -2 and 12. That's the second part. The parabola will have an equation of the form x squared is equal to 4cy, because the axis is vertical and the vertex is at the origin. Since the point -2 and 12 is on the graph, it must satisfy this equation. Remember, we had this on our summary sheet. X squared is equal to 4cy. We substitute for x minus 2, substitute for y 12, and we just simply solve for c. Then we get c is equal to 1/12. So now we have our equation. X squared is equal to 4 times 1/12 y. Or we can write it as 1/3 y, or y is equal to 3x squared. If you just multiply both sides by 3. The parabola with the vertex hk has an equation of the form x minus h squared minus 4c times y minus k. This would be another formula you should include it in your summary sheet, where the focus is the distance, absolute value of c from the vertex. Graph the parabola x equal to -1/8, y plus 3 squared plus 2. Label the vertex, focus, and directrix. You want to rewrite the equation in the form y minus k squared is equal to 4c times x minus 8. This was one of the formulas that we should have in our summary sheet. So let's start with subtracting 2 from both sides of the equation here. We get x minus 2 is equal to -1/8 times y plus 3 squared. I'm going to multiply both sides by -8. So I get -8 times x minus 2 is equal to y plus 3 squared. So I would have then y plus 3 squared is equal to -8 times x minus 2. This is what we are trying to make our equation look like, which is right there. And we've done it. We have now y plus 3 squared equal to -8 times x minus 2. So you can see my k would be equal to -3. 4c would be equal to -8. So I can solve for c. And I know my h is equal to 2 when I write it in this form. So the vertex is 2 and -3. Since 4c is equal to -8, we can solve for c by dividing both sides by 4. So c is equal to -2. And the parabola opens to the left. The focus is 2 units to the left of the vertex, and the directrix is 2 units to the right of the vertex. The focus is at the point 0, -3, and the directrix will be x is equal to 4, as you can see on the graph. Write an equation for the parabola with focus 2 and 2 and vertex -1 and 2. Focus lies to right of the vertex. Parabola has a horizontal axis and open to the right. Distance between the vertex and the focus is 2 minus -1, which is equal to 3. So c is equal to 3. So we have y minus 2 squared equal to 4 times 3 times x plus 1. We just substitute those into our general equation. You get y minus 2 squared is equal to 12 times x plus 1. Here we want to graph minus 2y squared plus 4y minus 3. Give the domain and range. So the first step is to complete the square. I don't really need this 3, this -3 here. I'm going to add 3 to both sides of the equation. I get x plus 3 equal to minus 2 times. We get x plus 3 equal to minus 2y squared plus 4y. In order to complete the square, I need to eliminate the coefficient of y squared. So I need to factor minus 2. I need to factor minus 2. I get minus 2 times y squared minus 2y. And now I'm going to take the coefficient of y, which is -2, and divide it by 2 and square it to see what I need to add here. So it would be -1 squared, which is 1. So I'm going to add 1 here. What we're really doing here is we're adding 1 and subtracting 1 inside the parentheses, and then I'm going to distribute this -2. So that becomes 2. So that's why we are going to subtract 2 from the left-hand side. I hope everybody can see this. Here we have to add and subtract 1 inside the parentheses, and when you distribute the -2, then you can see that would come out as 2 in the other side. Okay, so let me add this part. So over here I have x plus 3 on the left-hand side. On the right-hand side I have -2 times y squared minus 2y. Now we know we need to add 1 inside this parentheses to complete the square, but I'm going to add 1 and subtract 1. I'm really adding 0 here. This -2 belongs to each term. So here I get x plus 3 equal to -2 times x, -2 times y squared minus 2y plus 1. Now I don't really need this -1 inside the parentheses. I need to distribute this -2. That would become +2 when I move it outside the parentheses. Now if I move that to the other side of the equation, I get x plus 3 minus 2 is equal to what I have on the right-hand side. So there were a few steps we're missing to get to this point. So now it should be pretty clear. This would be equal to x plus 1 is equal to -2 times. Now I can complete the square, y minus 1 squared. Therefore, y minus 1 squared is equal to -1/2 x plus 1. You can divide both sides by -2. So that would become -1/2 on the other side. The parabola opens to the left, is narrower than the graph of x equal to y squared, and has the vertex of -1 and 1. You can graph that now. And the domain should be obvious. The domain would be from -infinity to this point here, -1. And the range would be all real numbers. Range would be from -infinity to positive. You can use our graphing calculator to graph this. If I solve for y, I get 1 plus and minus square root of x plus 1 over -2. As you can see the graph is done using the graphing calculator, using half of the parabola at the top and the other half in red shows at the bottom side. So you can look at this application problem. A Parkes radio telescope has a parabolic dish shapes with diameter is given to us as 210 feet. The depth is 32 feet. Because of this parabolic shape, distance rays hitting the dish are reflected directly toward the focus. We want to determine an equation describing this cross section by placing the vertex at the origin with parabola opening upward. Locate the vertex at the origin. The form of parabola is x squared minus 4cy. The parabola must pass through the points given as 210 over 2 and 32, which is 105 and 32. And we can look at the graph. So x squared is equal to 4cy I'm going to substitute for x 105 and y 32 so I can solve for c. That would be the value of c. The cross section can be modeled by the following equation. X squared is equal to 4cy. Now I know what c is. I'm going to substitute the value. So I would get x squared is equal to 11,025 over 32y. The receiver must be placed at the focus of the parabola. How far from the vertex of the parabolic dish should the receiver be located? The distance between the vertex and the focus is c. In the part A, we find the value of the c, which approximately is about 86.1. So the receiver should be located at this point, 0 and 86.1, or 86.1 feet above the vertex.